So in this video, I'm going to talk about making anhydrides. Um, so I'm going to talk about making anhydrides, esters, and carboxylic acids. Okay. Now, anhydride, esters, and amides, and not carboxylic acids, but amides. So these are amides. Okay. Now, we say an amide is usually represented by this functional group. So we have an R that's double bonded to a carbon. That has an oxygen that's sandwiched between two carbonyls. Okay, this is R prime. So this is our amide. Okay, this is our not amide, anhydride, and then we say an amide. Okay, we say an amides are usually this R that's bonded to a carbonyl that has this N R prime beside it. These are what we call amides. Okay, and then we say esters are usually some R that's bonded to a carbonyl that has an O that has an R group on it. These are what we call esters. Okay, now how do we make them? Well, first we need to make acid chlorides. Remember, we say acid chloride is actually the most reactive out of all these. So if I take benzoic acid, if I take benzoic acid and then add SOCl2, okay, I'll actually get the acid chloride. Okay, now the acid chloride is what we use to make a lot of things. So if I take the same acid chloride here and I add a carboxylic acid, so in this case, I'm going to add this compound. This is propanoic acid. Well, the oxygen on the carbon adjacent to the carbon will actually come and attack and displace the chlorine, and in this case, we actually form our anhydride. Okay, we're going to lose a proton in the case root. Okay, right? Because remember, oxygen is going to be positively charged, and then we're actually going to lose the proton to give us a neutral molecule. So there's our anhydride. Also, what happens if I take this acid chloride here and I add a carboxylic acid? Well, again, it's going to be my nucleophile. Oxygen is going to attack, displace the chlorine, and so I come to a structure that looks like this with the loss of a hydrogen. I come to this anhydride. Okay, so again, nothing more difficult. I take an acid chloride and a carboxylic acid, I get my anhydride. So that's how we make anhydrides. So let's talk about making esters. Okay, if I take an acid chloride, yeah, so let's use this molecule. Okay, so if I take an acid chloride plus an alcohol, just a regular alcohol, yeah, so in this case I'm using methanol. My alcohol, my OH is my nucleophile, my O is going to be my nucleophile. It's going to attack and displace the chlorine. And in this case, with the loss of a hydrogen, we'll actually form this. So we still keep our double bond. There's the rest of our molecule. This now is going to be bonded to an oxygen that has a CH3. Okay, and this is the structure that we get. Notice that there's our ester. Okay, same thing if I take, C2L chloride and I add ethanol. Okay, what will I get? Well, my oxygen is going to be my nucleophile. It will attack, displace the chlorine, so we come to a structure that looks like this. Okay, so there is my ester, and this is ethyl acetate. Okay, so that is ethyl acetate. Now I want to talk about making carboxylic acids, and I know I crossed it out initially, but I just got confused for a minute. But we're talking about making carboxylic acids, and this is from acid chloride. So if I take benzoyl chloride in this case, and what you add is actually water. If you add water, you'll actually get the acid chloride. So what's going to happen? It's going to attack and displace the chlorine. And so we have a carbonyl that's bonded to an oxygen with two hydrogens. So that means it has a +1 formal charge. Okay, and then one of these hydrogens will come in and form and give that lone pair to give that neutral compound. So now we have benzoic acid. Okay, so remember, any acid, chloride, and water, we make the carboxylic acids. So carboxylic acids. So let's talk about making amides. Okay. If I take an acid chloride and I add ammonia, let's use a simple nitrogenous molecule. So if I add ammonia, nitrogen will be my lone pair. I will attack, displace my chlorine. I'll actually lose a hydrogen in the process. So this is now bonded to 3 hydrogens. Nitrogen, 4 bonds. We know that's a +1 formal charge. This will come in. One of the bonds will break and come in to give the nitrogen its lone pairs. And so we come to a structure that looks like this. Yeah. So there's our amide. We have the carbonyl adjacent to the NH group, and there's our amide. And this is actually called cetamide. Cetamide. Okay, so there's our amide. Okay, and this happens with anything. Again, I could take, this same acid chloride and add, I could add this molecule, my methylamine. Yeah, so this would actually come and attack, displace my chlorine, and so I have my oxygen that will lose a hydrogen, so this now becomes an NH, and I have my CH3. There goes my amide again. So an acid chloride and any nitrogenous molecule will give you that amide. Okay, and you can kind of see the pattern here. So let's talk about making esters. Yeah, let's talk about making esters. Well, I just did, but let me give you a different example. Okay, so it so happens that if I take an anhydride and this is simple alcohol, I will actually make the ester. Okay, so let's look at just another example. I just revisited backwards, but let's get some more practice in. So if I take this compound here and I add a simple anhydride, yeah, what will I get? Well, what would be my nucleophile? Actually, that's a good question. Well, always remember that the oxygen of just a simple alcoholic group is more reactive than the oxygen for carboxylic acid. And so actually this will be my nucleophile. It will attack one of the carbonyl carbons and displace the leaving group. Okay, so it will displace the leaving group. And so in that case, we'll come to a structure that looks like this. We still have our carboxylic acid group here. Now this oxygen will lose a hydrogen from the plus charge, and now it's going to be bonded to a carbonyl that has a carbon and that's CH3 there. Okay. So this is actually, we actually form acetyl salicylic acid, or you could have called this aspirin. This is actually aspirin. Okay. Now with acid, yeah, I forgot, we got to add this in acid. With acid, remember we form a leaving group, yeah, which will be, this is an O minus, yeah. And with acid, it'll actually get that proton to reform water in solution. Okay, and so the two products of this reaction, we have an alcohol. Yeah, so we get acetic acid. We get acetic acid and aspirin. Okay, so these are the general forms of making amides, carboxylic acids, anhydrides, esters, and even acid chlorides.